Hi, so I'll probably put an introductory video on at some point, but I would like to go through some of the key questions you'll get on the integration topic. So the first few videos we'll look at how to integrate, so I've got a few standard questions laid out here, and then we'll move on to more classic, sort of trickier integration questions where we're actually working out areas, okay, so areas below graphs and areas between between curves or between two functions. So that's the more standard question. And to finish off, we'll look at using, if you excuse the pun, integrating our integration skills with some of the other skills, so polynomials, and then this is a quadratics question. Okay, so there are three main parts we're going to run through over the course of these videos, and I'll maybe come back at some point and do just like a little intro, but at its heart, integration is working out the area below a curve, and also it's the opposite of differentiation. So all the skills we use in differentiation, we're going to be using here in integration. So the first thing I do when I do these questions, right, this is, integrate this function. The first thing I tend to do, something along the lines of, x squared gives me 2x. I tend to write that just to remind me when I'm differentiating, that's what happens. Okay, if I differentiate, I go from here to here. Integration goes back the way. So I always look at this and go, oh, that's right, yeah. I add 1 onto the power, so suddenly 1 becomes 2, and I divide. It's as simple as that. So for integrating, I'm going that way. Sorry, other way around. Differentiating, I'm going that way. And if I'm integrating, I'm going the other way. So the rule we've got is add 1 to the power, and then we're going to divide by that. If you remember that, you're doing okay. And however, you need to remember that. Whatever works for you, do it. That works for me. I just remember, oh yeah, add 1 and divide. So here we go. Let's get cracking. So first thing we'll do here is I'm just going to set it up. So 6x to the half, that's what the root means. Take away 4x to the negative 3 plus 5. Just the exact same as when we were doing differentiation. Pardon me. I mean, we need to get our our fractions and our coefficients in a nice line. We can't be having surds, unlike over here we can't have our divide, we need a single line. So now I'm able to differentiate with respect to x. So let's see, if I add 1 onto the power, I'm going to get 3 halves. And just think about that, you could draw that out over here if you want. You could say a half plus 1, which is the same as a half, plus 2 halves, which is 3 halves. You could do that. Or you could graphically show it. You could say, okay, well, a half, if I add on 1, well, 1 pizza has got 2 halves, doesn't it? So I've got 1, 2, 3 halves. So something like that. So add 1 on, and I'm going to divide by that new power. And the 6 just stays where it is. Over here, I'm going to add 1 on. Now remember, that's negative 2. If you add 1, you're going up the number line. The negative 4 stays where it is, and I'm going to divide by my new power. And here 5 just becomes 5x, because if you think about it, if I differentiate 5x, I would have gotten x. And the other thing we need to know is c, if I integrate c, because if I had a number, 4 here, I differentiated, it would disappear. So we could have a number which we don't know. So this is us halfway there. We just need to tidy this up now. This is the bit that people get confused at. I'm going to just do this one. This is the easiest bit. So negative 4 divided by negative 2 is just plus 2x to the negative 2. So that's the easy bit. Just in here, 2 negatives, we get positive, 4 divided by 2. This looks quite tricky. And again, I would just do something on the side. I would say 6 divided by 3 over 2. And I always teach the kids, keep, flip, change, KFC. Okay, sorry, it's not close. Keep, flip, change, but the F is on the end there. Sorry, keep, flip, change. Yeah, one of these days I might get some, I don't know, some marketing money from KFC all the times I say it. Keep, flip, change. This stays the same. Change the sign and flip that around. So that's going to give me 12 over 3, which is simply 4. Now the lazy way to do it is I kind of look and think, well, this ends up multiplying by this. Yeah, so 2 times 6 is 12, divided by 3 is 4. But if you need to do your sum, that's absolutely fine. But as you do more and more, you might realise, oh yeah, this one just comes up to the top. So that becomes 4x to the 3 over 2. And as you see there, we've got the right answer, but I would actually rather, I think I would write it out with 4 root x cubed, and that's plus 2 over x squared. When we cross the line, we change the sign and the 2 stays where it is, plus 5x plus c. Fantastic. So that's a nice question. For 4 marks, that's very good. Okay, add 1, divide by the new power. Add 1, divide by the new power. Remember, this becomes 5x, and you would always be adding your plus c, because if I differentiate this, I should be right back to where I started. So 5x becomes 5, and there could have been a number here. If I differentiate, 1, 2, 3, 4, 5, it disappears. So that's why we have our plus c. Right, let's try another one. So same again. The only thing I'm going to do this time is I'm going to start off breaking up the big fraction into small fractions. Yeah. So that is exactly the same as this. And the only thing that the only reason I've done this is to make it nice and easy to apply my index laws. So now I can say I'm going to integrate. The 4 stays where it is, that becomes x because I'm doing takeaways, 3 take away 2. And this one, I change the sign because I've crossed the line. Okay, and be careful, we've not actually integrated yet. We've just set it up. Okay, so when you see this, you need to break up into the fractions and do your power rules. Okay, so now I'm going to integrate. I'm going to add 1, so I get x squared. I'm going to divide by the new power, and the 4 stays where it is. I'm going to add 1, going to divide by the new power, and I'm going to get my plus c. Don't forget the plus c. So that simply becomes 4 divided by 2, 2x squared, take away x to the negative 1 plus c. And again, just to be a wee bit neat, I'm going to write that as 2x squared, take away 1 over x plus c. So I think the one that people always forget is the c. Don't forget that. People always get confused when they add 1. I think they put that as -3, so don't make that mistake. And you're dividing by the new power as well. So when I write it, you see I write the power to the new power first, and then divide, and then put the 4 in. Okay. So just whatever works for you, just make sure you're not making those mistakes. And the last 2 questions, but I'll do that one last. I'll do this next, because that's more similar. So this time, it's we've got an x in front of the bracket. So I would set this up by multiplying the bracket out first. Sorry, that's a really terrible integral sign, isn't it? So that'll be 3x squared plus 2x dx. Okay, so I'm integrating this function with respect to x, but I've just multiplied my bracket out. So add 1 on, x cubed, and divide by the new power, 3 stays where it is. Add 1 on, divide by the new power, and the 2 stays where it is, plus c. 3's cancel out, 2's cancel out, I am left with x cubed plus x squared plus c. Okay. So I'll do this one in the next video. I don't have quite good time this time round, but that's our basic introduction to applying integration. I might do one about what it means exactly, but it's the opposite of differentiation, and we're adding 1 to the power and dividing. Just make sure you know how to set it up. So we need to get rid of our surds as we did with differentiation. You need to remember to take away your powers if you're dividing, and if you're multiplying a bracket out, you're adding the powers, yeah, because there's a little 1 in here, isn't there? So 1 plus 1 gives me x squared. Yeah, 2 times x, 2x. And don't forget your plus c. If you want to check you've done it right, then just differentiate what you've got. Okay, so if this is my function, if I differentiate that, let's have a look. And differentiate is obviously much easier. Multiply, take away 1 plus 2x. That number would disappear. Yes, I'm right back to where I started. Okay? So if you need to check it, you can always differentiate. All right, so in the next video, we're going to start looking more at the areas and under graphs. All right, nice.